Here on the equator, UV is a daily reality. Awareness of personal UV protection is increasing among the population as well, especially when we are more educated about the health impact of UV exposure. Research has shown that UVB drives sunburn and contributes to skin cancer risk, while UVA penetrates deeper, linked to photoaging such as wrinkles and sunspots and eye damage like cataracts over time. Hence, sunscreen has slowly been integrated into our daily routine. At least that's the case for me. That's when I start to wonder, how much UV actually gets through my sunscreen? I decided to test the UV transmission of 3 of my different sunscreens. I also borrowed 3 other brands from my dear friend Rayan for comparison. For anonymity, the sunscreens are labelled A to F. To satisfy my curiosity, I am in Lab 7 to run a small test. I'm using the Ocean View software, a spectrometer, a spectral clip, a tungsten halogen light source, and quartz lights. For each sunscreen, I spread the same amount on a slide to approximate how I would apply it on skin. After measuring a clean slide as the control, I placed the coated slide in the spectral clip and recorded its percent transmission in Ocean View. Now, let's look at the results together. Besides the overall percent transmission, pay attention to the wavelength as well. Sunscreen A, shown in red, displays high UV transmission, only blocking 10 to 25% of UV. Sunscreen B, shown in orange, is blocking around 90% of UV below 350 nanometers. It also reduces roughly 20% of visible light, likely due to color-correcting pigments in the product. Sunscreen C, shown in yellow, has similar UVA blocking as B, but with an earlier, steeper cutoff. It blocks mid-UVA sooner. However, it shows high transmission in early UVB. Note that visible light transmission is high, so it stays clearer on skin. Sunscreen D, shown in green, is the top performer so far. It has a UV block of more than 95% with about 80% of visible light transmitted. Its cutoff is earlier than B and C, covering more of the UVA band. Sunscreen E, shown in blue, displays roughly 60% block in UVA, which provides less ideal protection. Sunscreen F, shown in purple, is similar to D, with an even steeper drop into low transmission, making it another top performer. Hence, the best UV blocking in my setup is D and F. C gives decent UV blocking while keeping skin tone closer to natural through high visible transmission. A performed worst. Here's a fun fact. I snagged sunscreen A for 20% of retail from an unverified online listing, and it behaved like a 20% sunscreen in my measurements. This highlights the value of purchasing from reputable vendors and verifying broad spectrum claims. There are a few limitations in my measurements. Firstly, quartz lights aren't skin. They do not mimic the texture, oils, and scattering properties of human skin. Our tungsten halogen light source also differs from sunlight and is relatively weak below the 330 nanometers, underrepresenting UVB in the measurements. Finally, we did not model real-world wear and tear, so in-use performance may vary. Future studies could look into using skin-like substrate to replace quartz lights. Testing real-world variables, for example time on skin, sweat, rubbing or abrasion, water immersion, could be used to assess durability. A solar simulator could be explored with full UV spectrum in the experiment.